Today we're going to look at a more visual meaning of determinants. So I'm going to plot the 2x2 matrix that I have onto the xy coordinate plane. I'm going to assume that A, B, C, D are all positive values just for visual understanding, and also it's easy to plot in the first quadrant. So let's just start. So I'm going to first plot the vector AB. So the vector AB, let's say this is A, this is B. The vector AB would be something like that, and that's the endpoint, right? And it would go something like this. Okay, and I also want to plot the vector CD. So where's CD? Or let's just say C is here. Actually, nah. C is here. And that's D. You know what? I'll make D a bit lower. D. So we can just draw our vector. And what I want to do here is I want to make a parallelogram out of these vectors. You'll see why later. So this point is gonna be, this point here is gonna be AB, right? Well, I want to start from this point and then copy and paste this vector over here. So I'll just go ahead and copy and paste the vector. So if I just copy and paste, okay, there we go. And I put the resulting vector here. These two are the same vectors, right? And then if I copy and paste the vector below, if I copy and paste this vector here, like that, and I'll paste it here, so that I have a parallelogram. And the determinant of the matrix ABCD is, well, it's essentially the area of this parallelogram. So we'll see that. But first, I want to figure out the coordinates of this point. Now this point is gonna be, so we have A plus D, A plus C, and then B plus D. So why? Because if you paste this over here, then this goes C units horizontally, so this part also goes C units horizontally. And the same thing, if you paste this vector above, then this part is gonna go B units vertically. So, okay, so let's just keep going on. So how do we find the area of this? Because we want base times height, right? So base is gonna be something, so base is one of these sides. Height is probably like this, but that's really weird and that's really hard to find. We can find it, but it'll take a long time. So maybe we should just do things easier. So let's say I had a large rectangle, like this. And then, essentially what I decided to do is that I'll figure out the area of this rectangle, so the other two sides are on the x and y axis. I'll figure out the area of this rectangle, and then I'll subtract the other areas that we don't need, and then we'll get the area of the parallelogram. Okay, so let's just figure out the area of this rectangle. Well, that's easy. It's just A plus C times B times C, because this is one of the vertices, and this is like A plus C is the width, B plus D is the length. So we have to subtract this though by a few things. So let's just try to split this up. Split the remaining areas that we don't want up, so that we know what we're trying to figure out. So we can split this up into, so a rectangle, two triangles, and also here, the same thing, a rectangle, two triangles. Since the shape is symmetric, we only have to figure out this side. And then we can just multiply that by 2 and then minus whatever area we get. So let's do the rectangle. The rectangle is going to be, well, the rectangle's area, so this part is going to be B, or no, wait, sorry, this part, yeah, this part is going to be C, so the length here is going to be C. And then the length here is going to be, well, that length is going to be B. So we have 2 times BC, because we just figure out one side, and then we apply the area to the other side because the shape is symmetric. So we minus 2 times BC plus the area of this triangle. So what's the area of this triangle over here? The base is C, and then the height is, or let's see, the height is actually just D times 1/2, and then you add this by the area of another triangle, the other triangle. The other triangle has base A, and then it has height B times 1/2. So if you expand everything, you get AB plus AD plus BC plus CD minus 2BC minus CD minus AB. And you cross like terms out. Like that, and then we're actually just left with a determinant, because essentially what we're left with is, so we're left with, well, AD minus BC. So that's just a determinant of the 2 by 2 matrix, and that's just the area of the parallelogram. So let's move on to 3 by 3 matrix. So for the 3 by 3 matrix, I'm just gonna try to draw a graph, but the shape, essentially the 3D shape we get from a 3 by 3 matrix, like this one, A, B, C, D, E, F, G, H, I, is a parallelepiped. So parallelepiped. I don't know if I spelled that right, but it's just saying that all 6 faces of the 3D shape are parallelograms. So I'm going to try to draw this. So like this, that's our first face. And then also like, so the top might be like that, so that's a parallelogram, not a rectangle. The other side might be like this. The other side is like this. And then also that the inners are probably like this. And also like that. So this is our parallelepiped, and essentially the determinant of this, a determinant of a 3 by 3 matrix like this is actually just the area of this parallelepiped. So probably I think what you do is you first figure out the area of the rectangular prism here, the rectangular prism like that. That actually surrounds this parallelepiped, and then you subtract whatever area you have left that you don't need. So actually the determinant is just A times the determinant of EFHI minus B times the determinant of DFGI plus C times the determinant of DEGH. Okay, so this is actually just the area of the parallelepiped if you have a lot of time and patience and try to figure out the area. So thanks for watching.